Hi guys, good morning. Welcome back to the new video. So, oh god, this question is one of the kind we have not seen in the last 3 months. So basically, okay, I'll firstly say if you wanna skip this part, skip next 15-20 seconds, but it's a good mixture of applying firstly weighted median and then applying a trinary search. That has not been a case so far. We have seen independently both of these, but not together. So yeah, let's see this problem. It's a hard, but not, I will not say it's a hard. It's a medium to medium hard problem. Not hard actually, because the concept being used are very standard. Cool. If you not know, please mark these concepts after doing this problem in your notes or somewhere else that you know, okay, this is one such concept I need to remember for future. Now, the problem says, okay, minimum cost to make array equal. For sure, the problem is it's the same. You are given a zero next integer array called as nums and cost consisting of each n positive integers. Now, what I have to do is, the operation I can apply is, operation is increase or decrease any element of the array nums by 1. The operation I can apply is increase or decrease any element of nums by 1, and the cost of one operation of the ith element is the cost of I. Cool. I have to make all the array of nums as equal, and I have to find, okay, what is the minimum cost I would incur for that. Now, for sure, as usual, what happens is whensoever I come to a problem, I see its example and try to find and build intuition out of the example itself. I don't put my mind much. That's it. I have this nums. I have this cost. Okay. I want to make all the array elements of nums equal. Okay, that array elements of nums equal, and then I have to also consider the cost while making this array elements as equal. That is bigger problem, right? What if I just have only small problem, like whatever I spoke, I just broke that into two parts. I have to make all the array elements of nums as equal and also consider the cost associated with each element. If I just say, okay, let's say I forget the cost as of now. Now my task is make all the array elements of nums as equal. I have the array elements as 1, 3, 5 and 2. Let's say I just, okay, I can't remove the cost, else the cost will be 0. Okay, let's say make the cost same for everyone. Okay, it's 1, 1, 1 and 1. The cost for everyone is same. It's 1. So I can modify any element and I can make any element as equal. Now, as soon as you hear this word, okay, you have some numbers, and you can increase or decrease any number possible, and you have to make all the numbers as same. Can't we imagine these numbers in a number line? And see, it's a very standard algorithm. It's a very standard problem. Very, very, very standard. It's the reason because see, as soon as I read this problem, standardly I went to the coordinate path. And that's the reason I'm just showing you that path only, how to reach that path, and you should start from that path itself. Okay, I just imagine I only have these nums, and these nums are, okay, the numbers, and I can increase or decrease any number, which means I can increase it to 2, I can decrease it to 2, I can decrease 5 to 4, and I can increase any number, decrease any number, and then my ultimate aim is to reach or make every number reach to one number. I can imagine these numbers as, okay, they are plotted on my coordinate x-axis. Okay, these are all the numbers. And what I have to do is I can decrease or increase any number, which means I can shift this number in the x-axis to the left or the x-axis to the right. But I want to remake all of them equal. So if you have some points on your number line like this, and you have to make all of them equal, so is it good that you will bring all the elements to the left side? Because then it will travel this, it will travel this, it will travel this, it will travel this, it will travel this. Is it good? No, right? Or if I ask you, is it good to bring all the elements to the right side? Nah, right? Why it is in the case that I will bring all the elements to the mid? I will just bring all the elements to the mid so that everyone, see, whenever you ask your friend, okay, hey, yaar, we need to meet. So it's always good you meet at a middle point. If you have three friends, right? Now you all three want to meet. So isn't it good that you all three meet at the middle place, which means the friend 1, the friend 2 and the friend 3. He, let's say, has to travel 8 kilometers, you have to travel 9 kilometers. So if you meet at friend 1 place, so in total you have to travel, let's say it as 1 kilometer and 2 kilometers. So you all have to travel in total as 3 kilometers. While if I ask you, if you had to meet at friend 1 place, then friend 2 had to travel 1 kilometer, friend 3 had to travel 3 kilometers, in total 4 kilometers. That's bigger, right? Earlier I had only 3 kilometers. Now it's 4 kilometers. If the same case for friend 3, everyone has to reach there, 2 and again a 3, which is 5 kilometers. So it's always optimal to reach to the middle point. And it is what we usually do in our daily life also. We usually, okay, let's meet up at the middle point so that everyone can actually come to the middle point, and it is the shortest possible path. One part, okay, minimum cost. If the cost is same, and everyone has to come to a middle point, I will just say, okay, come to the middle point. And that's how I just transform this problem. Okay, nums, then okay, it is just the numbers I can simply plot in the number line. I can just bring all the numbers to the middle number. That's it. Which means, and for sure, when I say middle number, it can be either the median itself, which means if in this case I had these 3 friends, so I brought all of them to the friend 2 place. Let's say if I had 4 friends, so I can either do one thing, I can bring everyone to the friend 2 place or the friend 3 place, or maybe the mid of the friend 2 and friend 3. Every way, friend 2, friend 3, or the mid of friend 2 or friend 3, all of them will have the same answer, because it's just everyone has to travel that particular distance. So it's good. Either you can just bring to the median or to that end elements of the median. That's it. So okay, I got to know one thing. Okay, if I have these nums, I will bring all the elements of nums to the median. That's how one thing is solved, and that is what we saw in the intuition. Now it's for sure entirely intuitive. And please, anytime you just see, okay, bring the elements equal, make the elements equal, you can increase or decrease the element. Either if it says, okay, you can increase the element, you can decrease the element, please think of this way. Now, just to verify what we learned or what we saw was actually true or not, let's see. If we have the nums, as I saw, okay, let's have the same cost, because the cost was making me confused. So I just wanted, okay, let's keep cost aside. Let's try to imagine, okay, if all of them have the same cost or equal cost or maybe one cost, then what's the answer? So basically, if I just try, okay, make everyone as 1. So I would have brought everyone as 1 to the extreme point, 1, left extreme point. Then for sure, 1 would have been 0. But as you see, it just keeps on increasing. The difference, it keeps on increasing. And thus, the total cost would have been 7. How I find this cost? If to make everyone as 1, I need to make this one as 1. It's already 1, so the cost is 0. Make 2 as 1. The cost will be 1. Make 3 as 1, the cost will be 2. Make 5 as 1, the cost will be 4. And for sure, the cost for every operation of transformation is 1. So for sure, 1 into 1, 2 into 1, 4 into 1, it's nothing but 7. That's it. I just had the same cost. Now, if I had to bring everyone equal to 2, which means everyone has to bring to here, which is one of the medians, because the median is this and this, both, right? So I will just do one thing. Okay, 1 has to go to 2, increase by 1. 2 same, 3 reduce, 5 reduce, answer is 5, which means the cost in total cost. 3, it is another median, so for sure it should also have the minimum cost. Okay, it will just get transformed, the cost is 5. Again, if I just reach to a 5, which is actually the extreme end, again it will have high value, and again easy, so it is the 9. So I can easily see if I just plot this particular stuff. Okay, I just try to make equal to 1. The cost incurred was 7. I tried to make equal to 2. The cost incurred was 5. Cost incurred was 5. Cost incurred was 9. That's the reason. As you just bring everything down to the median, the cost automatically, the distance automatically, it just tries to reduce. The total cost, it just automatically tries to reduce. That's the reason. I can also see this graph. Okay, by this graph itself, I know whenever I am bringing things down x-axis wise, it is trying to get lowered, and that is how you know. Okay, I can easily make a graph out of it. A graph is just to show you, okay, that graph can be made, and that graph shows us it is always in the mid that you will find the minimum value, because it's a convex curve. Now, for sure, you know that you will find the median, and via that median, you will just get it. But you assumed one thing right before. The cost is 1, because so as to just only operate on nums. You just use, okay, I will just forget I have a cost something. I will just use nums. Then you use nums, but actually you are also having the cost. Now, when the cost was 1, when we just assume, okay, everyone has the same cost and so on, then we imagine that, okay, 1 as a number, it has a cost of 1. Now, 1 as a number, to have an operation on it, the cost is 2. Or I can also refer as, if I had 2 ones, then the cost is simply a 1 for every of those 2 ones. If I had 5 as a number and the cost is 1, okay, the cost is 1. If I had 2 as a number and the cost is 14, so I can imagine I have 14 twos, and everyone has a cost of 1. It will be the same thing. That's the reason I just can say, okay, this nums having this cost, I can just infer as, okay, 1 has a cost of 2, or I can say 2 ones have a cost of 1, 3 threes have a cost of 1, 5 is nothing but 1 itself, and then 14, 2 is 14 times having the cost of 1, That is how I can simply say, okay, I have 1, I have 4, I have 2 14 times, I have 3 3 times, and I have 5 1 time. Now, you also remember, okay, to actually find the median, you need to sort things out, because it was 1 3 5 2. To find the median itself, you have to sort it. 1 2 5 1 2 3 5, and that's how you can just get, okay, it is a median. That's the reason I also have to. I have this nums, I have this cost. I also know one thing. These two should be attached. So I have to firstly attach them. 1 has a cost of 2. So I have to repeat 1 twice. I have to repeat 3 thrice. I have to repeat 5 1 time. I have to repeat 2 14 times. So I have to attach these. And then I have to sort my nums. Because for sure, my nums need to be sorted to find the median. Now I have this nums. The cost is nothing but 1 for everyone. Because I imagine my answer at the cost of 1. That's the reason I just can transform my nums itself. Okay, everyone has a cost of 1 now. Now it is my num. It is called. We were finding median at this. Now making this array and then finding median on this is nothing but a weighted median you are finding out. That is how you learn another new concept. See, firstly you learned one concept. Okay, that median actually brings in the smallest possible cost, and that we use in a daily life also. Now to transform the weight for a number, we transform that number itself into multiple numbers, and that is called as a weighted median. Now what will happen is, now I want to find the median of this. That's nothing but a 2 itself. So it will just point anywhere here. Now that will just say, okay, transform this nums entirely to a 2. Because simply it's just a weighted median. So I just have median, that's 2. And I will bring every number to that median. If I have 1 1, so I will just transform that 1 1 to 2. So every one have a corresponding 1 in a difference. These will have zeros. These will have a 1. And this will have a 3. Now, Aryan, shall I transform this entire nums into this particular big number? Shall I actually stretch it? No, it's not required. Why? To find, see, now, why you just transform this into this nums? Because you want to find the median, right? You can find the median by just knowing the frequency also. You just need, okay, the frequency of 1 is 2, the frequency of 2 is 14, the frequency of 3 is 3, the frequency of 1 is, the frequency of 5 is 1, and it is exactly same as the cost. So now I know, okay, if I know, okay, the total number of elements are 14, 15, 16, 17, 19, 20, 20 elements are there. So median is the 10th number. So 2 numbers exhausted. Now I want 8th number. 8th number will come somewhere in that 14 range only. For sure, my median is itself a 2 because 8 is less than 14. So now I know, okay, my median is 2. Now to find, okay, what is the cost? What I will do is, I had 2 ones and I need to transform. I transform this 1 to a 2. So 1 minus 2. I transform it to 2, but the count was actually a 2. So basically I do a ABS of this. That will give me, okay, answer is 1 into the frequency of these count is 2. So you will see that count is actually a 2. Now if I have these 3s, I know the 3 will be transformed to a 2. So the cost difference will be a 1, and that count is nothing but a 3. That I know it's a count is, that count is actually a 3. That count is a 3. That 3 was a number. I didn't transform to a 2 because I know the median is 2, and that's the reason I will just get, okay, the total cost is 1 into 3, which is 3. If I had a 5, simply 5 minus 2, and the frequency is 1, 3 into 1, which is actually a 3. That is how I can simply, I don't have to make it this entire nums again. Simply, I know the frequency is nothing but the cost. I know the median. I will just find the median by simply iterating on my particular nums and see, okay, what is the cost like and all that stuff. I can simply find my median. When I know the median, I will simply go and find, okay, what is the cost like? That's how you can simply solve this problem. That's the reason. You just learned two big concepts in this, and please remember them. Now, simply going on to the code, as we go on, I just initially said that I have to attach the nums with the cost. I will attach the nums to the cost attached. Now I need to sort because I need to find median on the basis of nums. So I will sort, and that will be sorted on the basis of nums. Cool, sorted. Now I need to know, okay, what is the count, because as you remember, I need to know what is the total count, which was actually a 20, because by that total count itself I will know the median, right? So I will just go, okay, the cost, it is nothing but a cost, 2, 3, 1, 14, right? So I will just go and add a sum of my cost itself, which is vi dot second, which is nothing but a cost. I will have the total count, which is a total frequency of elements. Now, for sure, I want to find the median. I will simply go and keep on going. As I showed you, I will keep on going. I know my median is 10. So I'll keep on going 2. Okay, it's done. It's not a median. 8, 14. Oh, my median is nothing but here itself. So I just keep on going while my sum plus 1 by 2, and also my I is less than nums, because so as to not go beyond. And then I will just add in my total. If it is being added, median being updated, and I being done. As soon as my total becomes more, I know, okay, I have already got my median, and that is my median which I have. And I have to now make every element equal to my median. I know this median. I will just call this function, which will actually just say, okay, make everyone equal to that particular median. I know that is my x, which is the median. I have to make everyone equal to x. Simply, as I showed you, I will do a AI, that number minus x, and for sure ABS, because it can be positive negative also. And then the cost, it is nothing but a frequency. It is nothing but a frequency, as I showed you. Cool. From that, you will simply get the result. And that's how you can simply return the result. Because you knew one thing, I will make everyone equal to median. Everyone is made median. It is the minimum cost possible. Time is nothing but O of n log n, because you are sorting your vector, which you made right here, which you made vector. And also the space is O of n, because you are using this vector. Now I will ask you as an interviewer, hey, can you optimize this? Because it is, firstly, it is a very good thing that you thought of this weighted median stuff, and also that the answer can be reached by median. And I also proved that, okay, why it is actually the case. I'll ask you, firstly, the code is down below for you to copy paste. And for the people asking where is the code of Java and Python, you can simply go on chat GPT and BART and simply just write this code, copy paste this code, and just say, okay, convert this code to a Java code. It will just simply convert. That's not a big deal. Now I'll ask you to optimize it. Optimize as in what you can do. You can maybe optimize time or maybe space. Time looks a bit skeptical to optimize, because okay, O of n I can't do, and log n factor will come in picture because I need to solve or do something else. Linearly, a first thing I can't do, because linearly nothing seems to be there. No 2 pointers, no sliding window, nothing seems to be there. But if I just look at that graph which I made, I could see it's decreasing and it's increasing. Oh, decreasing and increasing. I know something as a binary search, which is decreasing and increasing. If it is both, it's a trinary search I can apply, which means if I have 2 points, y1, y2, and I know, okay, y1 and y2, the graph is increasing, y1 is less than y2. So for sure, I need to bring my points to the left side. I will bring everything to the left side, which means I will shift my right. I will bound my right. If I know my y1 and y2 is something like this, I know my y2 is less than y1. So I know, okay, I need to shift everything to the right. I am shifting everything to the left. Now by this, I can actually know, okay, I will just, as we simply do in a linear search, I take a mid, which is X, and then I just try to bring it to some point. If I just want to decrease it, I just decrease it. If I want to increase it, I just increase it by simply restricting the boundary. Now, in this tiny search, I know I have the point X. I want to know, shall I go to the left or shall I go to the right? By this, I know, okay, I will just get a X and X plus 1. By this X and X plus 1, what I can do is, if my X plus 1 are the 2 points, if my X plus 1 is less, I will go to the left, which means X plus 1 value. When I say value, it's nothing but y2. See, X is nothing but, okay, what you are placing in. X was nothing but, as you can see here, X was nothing but the value 2, the value 3, the value 1, the value 5. The actual value for the 2 was 5. Actual value for 3 was 5. Actual value for 1 was 7. Actual value for 5 was 9. So, if I just take x1, x and x1, x, firstly I just choose a mid as x, and then x1 is nothing but the next number. By this, I will know the 2 consecutive points. Now I know the 2 consecutive points. If I know these 2 points and I want to know, shall I move left in my graph or shall I move right in my graph? Because it's the only reason. You have a binary search, in that you just need to know, shall I move left? Shall I move right? Shall I move down? Shall I move up? That's the reason. It's just you're confused where to move. For that, I just took these 2 points, consecutive points. If my x1 is less, move to the right, go to the right. If my x is less, go to the left, because ultimately my main target was to reach to the most bottommost point, which is nothing but this particular point, which is the lowest point. And that is how I can simply reach to my bottommost point. How? By simply doing a binary search with a slight modification. It is called as a trinary search. That's another big thing which you are studying in this particular problem, that how you can use an actual trinary search in this problem. And how you use that? Simply by taking x and x plus 1, by grabbing y1 and y2 for those corresponding x1 and x2, y1 and y2. Now I will just say, okay, y1 is less than y2, great. Y2 is less than y1, great. Y1 is less than y2, I need to go to the left. Y2 is less than y1, I need to go to the right. That is how I can simply say I will simply get my minimum of y1 and y2, because ultimately I just want to reach the bottommost point. y1 and y2, I just need minimum of both, because I need to reach the minimum, this particular point, minimum of y. Simply seeing the code, as we saw, we have an L and R. Now you will say, okay, how L and R? It is as simple as that. Where is the code gone? Yeah. You know, you have your range of nums, as I showed you. You have to do a binary search on your median itself, because median, it is in your hand. You have to find a point, because your number line was these points itself, right? Your number line was these points. These points are nothing but nums. So nums, you have to apply a binary search on that, kind of a trinary search. But yeah, simply saying binary search on that. When I say binary search on these nums of I, which is nothing but 1 so you know, okay, your L range starts from 0, your R range starts from 1 Now you have your L, you have your R. Now you can simply go and find your X. X, I showed you, it's in the number line of X. And for sure, your result, initially I just had it maximum. And Aryan, for maximum, you take the median as 1. Because yeah, at the extreme points, which means either at the 1 or either at 1 it will be at max. So I initialize my result with the maximum value. Now I will simply apply a binary search. When I say binary search, it's a trinary search. Simply, the code is exactly same. While L is equal to R, I just find the mid. Mid is itself a X, which is nothing but a median I'm trying out. For that X, I know I can't simply go with 1X. I need to have a X and X plus 1. So that I can easily know, okay, X and X plus 1, either I have to go a left or a right. I will simply go and find by this y1 and y2. So I simply go, and for this X, I find, okay, hey, what is the, if I choose this X as a median, what is the y1 like? If I choose X plus 1 as the median, what is the y2 like? And simply, it is the same function which we saw earlier also. If I had a median as X, then what is the value? It just gives me, okay, if your median is X, then what is the cost, in total cost, which you will incur? the same function which we saw above also. Now, as I have y1 and y2, as I showed you above also, if y1 is less than y2, and firstly, you know that you have to update your result with the minimum of y1 and y2, because your y1 and y2 are simply these particular points on the y coordinate, and ultimately you need to reach at the lowest point. It can be here, it can be here also. So you need to reach the lowest point. So it can be y1 or y2 minimum anyway, right? So I just simply update my result by the minimum of y1 and y2. And now, how to know where to shift? Simply, as I know my y1 is less than y2, so I will simply go to the left. If my y1 is less than y2, I simply go to the left, which means I will shift my right to the mid. Mid is nothing but x, right? Else vice versa, I will shift my L to the right, which means L to the x plus 1. Ultimately, I will return my result. By this, you will see that your time velocity is O of n log A of I. A of I because it is 1 is 6. Earlier, it was O of n log n because of sorting. It is here because of binary search. And now, space is O of 1 because you are not using any extra space, any vector, anything like that. That's the reason. This problem you can solve by using first thing you should make sure that you have intuition of is, okay, your weighted median, how it is working, and then when you have that weighted median itself, then you can just optimize. Okay, just use that binary search, trinary search. Although simply thinking of trinary search also in the interview itself is actually also okay, but I highly recommend the main reason to show you weighted median, also the concept of median, that how the medians are actually good and necessary for to bring to the minimum cost. That okay, how the minimum cost is we get by simply bringing everyone to the median, and then how we use weighted median, and then how we use a trinary search. I hope that you guys got all three concepts. That was actually a very good problem. Please bookmark it, do anything what you want to do. Please make your notes. But yeah, that's actually a good problem. See you in another video. Take care. Bye.